Molality by Jesse Ryan and Joey Riley. I'm sure everyone here remembers moles and how we use them for various conversions. For example, the mole, which is written as 6.022 times 10 to the 23rd, can be used to convert atoms to grams. However, we rarely apply the mole to hands-on chemical practices. Today, you will be able to learn how we use moles to measure the concentration of solutes. This practice is called molality. Molality is the amount of solute divided by the mass of the solvent. When determining which substance is the solute or solvent, the solute is the substance being dissolved within the solvent. By using these measurements, we can find the concentration of the given solute. The concentration is the amount of a substance contained within the entire solution. So, we can calculate the concentration by using the equation molality equals the amount of solute over the mass of the solvent. Oftentimes, people confuse molality with molarity, even though there is a substantial difference. Molarity is the number of moles of a substance per liter of the solution. For example, a 1.0 molarity solution has 1 mole of solute per liter of the solution. When comparing this to molality, the same solution will have 1 mole of solute.
Molality is the moles of solute over the mass of a solvent in kilograms. So for number 1, it asks the molality of a solution made from 2.4 moles of sodium chloride and 0.80 kilograms of water. So you just plug each number into the equation where it's supposed to go. So you would do 2.4 moles of sodium chloride divided by 0.80 kilograms of water to get a molality of 3. For number 2, you have to convert because it only gives you the sodium hydroxide in grams and the water in grams, not kilograms. So to convert the 25 grams, you have to use the periodic table and find the molecular mass by adding each element together. So you would, to get 39.998 grams, so you would do 25 grams of sodium hydroxide and then multiply that by 1 mole of sodium hydroxide divided by 39.998 grams of sodium hydroxide to get 0.625 moles of sodium hydroxide. Then you have to convert 120 grams to kilograms, so you end up dividing by 1,000 and you would get 0.12 kilograms of water. And then you have to divide 0.625 moles of sodium hydroxide by 0.12 kilograms of water to get your molality of 5.21. Then for number 3, you have to manipulate the equation because it gives you a molality solution of 1.4, so you put that on the left side of the equation, and you set that equal to the 0.4 moles of sulfuric acid, and you're trying to find the kilograms in the denominator. So you end up dividing 0.4 by 1.4 to get 0.286 kilograms of water.
Alright, here we're measuring calcium chloride.
So we zeroed the scale with the dish, and then we added calcium chloride.
And what do we have? We have about 15.36 grams.
Next, we are finding how many grams of water. So Jesse's pouring 400 milliliters, which is 400 grams, which will convert into kilograms. Now we're going to mix the calcium chloride in the water to make a solution. And the calcium chloride is the solute and the water is the solvent.
Okay, so we got 15.36 grams of calcium chloride, and now we're going to make that into a molality. So we take the periodic table mass of calcium and chloride and we add them together, which is 40.08 plus 35.45, which gives us 75.53.
And then you divide the 15.36 by 75.53 to get your moles of 0.203. And then to find the kilograms of water, you take the 400 grams, divide that by 1,000 to get 0.4 kilograms. And then you divide your moles by your kilograms, so 0.203 divided by 0.4 to get a molality of 0.51.
down, 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 down.